Okay, so let's talk about normal boiling point. So we know that boiling is a definition or term that we use when we're talking about a liquid changing into a gas and it's happening inside the liquid. We boil things all the time when we're cooking, when we're creating pasta, and all of that. So it's something that we're very familiar with. So we know that there's a specific temperature at which this is going to start to happen. And normal boiling point is when we are talking about the temperature at which a liquid will start to boil at standard atmospheric pressure. Standard atmospheric pressure is a pressure at 1 atm. The other unit for it is 760 torr, and then we also will see it as 101.3 kPa. Now, all of these things are equal to one another, so they all mean the same pressure. They're just given in different units. 1 atm is usually the standard atmospheric pressure at sea level, and then as you go up to higher elevations, that number gets smaller. So the smaller that number goes, the smaller or less temperature needed to get it to boil. The higher that number goes, it's going to take more heat energy to get it to change into a gas. So that number is taken at a standard atmospheric pressure. We know that the normal boiling point of water is at 100 degrees Celsius. We've seen that before. We've also have graphs, and we see these graphs a lot in chemistry. And they can tell us a lot. So this graph here is a plot of pressure measured in kPa versus temperature in degrees Celsius. And we have four substances here that they have plotted. So they have ethyl ether, ethyl alcohol, water, and ethylene glycol. Now, some of the things that you can notice, you can see that the shape of this graph is a very kind of exponential style shape. You can also see that it has the three in kind of a like J curve, I guess. So it's an exponential style graph, and we don't have a real linear relationship. It's more exponential, and we can get some information off of here. So what you can see is you can see the pressure and the temperature at which these liquids started to boil. And if you look at standard atmospheric pressure, which in kPa is 101.3, you can find where it started, the temperature at which it started to boil. And this gives us our normal boiling points for these four substances. Now, ethylene glycol goes off the graph here, so we can't really see where its normal boiling point is, but we can expect it to be very high. We see ethyl ether, we have a boiling point of about 30, 36, 37 degrees Celsius. You have ethyl alcohol here at 80 degrees Celsius, and then you have water here at 100 degrees Celsius. Now, relating it back to the previous slide where I told you that the higher the pressure, the higher the temperature at which it's going to boil, and the lower the pressure, the lower the temperature it's going to boil. So we can also relate that back to its intermolecular forces, because intermolecular forces are the attractiveness to molecules or particles to stick to one another. The stronger that attractive force, the more energy it's going to take to make it boil so that it separates into a gas. So we can make a prediction here about the substance's intermolecular force. So of course, if it's going to start boiling at a lower temperature, we know that it probably doesn't have very strong intermolecular forces. So this graph tells us something about the forces within that substance. So I can look at this graph and make a prediction, and I can say that ethyl ether is probably the weakest intermolecular force out of all four of the substances. I can also probably predict from this graph that ethylene glycol is going to have the strongest intermolecular force. So I could almost rate these here from weakest force to strongest force. based off of the information on this graph and the relationship I know between intermolecular force and the temperature at which a substance will boil. So here I can say ethylene glycol, or I'm sorry, I'm going to do it this way. We're going to say ethyl ether. Ethyl ether has the weakest, and we've got ethyl alcohol would be next. Then we have water. And our strongest force here is going to be ethylene glycol. So I was able to make a prediction about the forces based off the relationship I know between intermolecular forces and melting or boiling points.